All right, so today we're going to look at the segment addition postulate. And so we have this problem here. If B is between A and C, AB equals 7, and AC equals 15, find BC. So the big thing that I want to note before we do anything else is how in a problem like this, if we are talking about a segment, we don't see a segment, I want you to draw the picture. Okay, so we're going to draw a representation of this problem. We're not going to just let it be as it is, but we're going to draw a picture, draw a representation of what we see. So in this, we're going to say if B is between A and C, so we're simply going to draw segment AC. Okay, so A will be on this side, and C will be here. Now the other part is when we're saying it's between. I want you to be careful that when you are putting B between A and C, make sure you don't put it in the middle. We're going to talk about midpoints later, and so I want you to put this kind of off to the side when you're placing point B, so that you don't end up thinking that it's going to be a midpoint. Okay. At this point, we're just going to label what we have. So we're being told that AB equals 7, so we'll place 7 here. We're being told that AC equals 15. Now we have to be careful with this because this is the whole piece, and so what I think is a good idea when you're doing this is to just to show that it's the whole piece. I think the best way to do it is like this. That's just showing that the entire thing is 15. Now, this also kind of reveals that this, as far as the segment addition postulate is going, is actually a subtraction problem because BC will equal AC minus AB. Okay, so in this case, that's going to be 15 minus 7. And BC is 8. Okay, so let's look at another example. So in this case, if B is between A and C, and I'm going to stop right there. So just in reading this much, I believe we have the evidence of what we are going to draw. So we're going to draw a picture just like we did in the last one. And so if B is between A and C, so we're going to draw that representation. So this will be point A and C, with B somewhere in between. Remember, we're not going to put it in the middle. At this point, we're going to label what we have. And so we're being told that AB is 3x plus 2. So we're going to label it with 3x plus 2. BC is 2x, that we get here. This piece is 2x. And AC is 22. And the same thing we did before, I'm just going to label that this way to show that it's the whole thing. Now, in using the segment addition postulate, at this point we're going to have to set up an equation. So this piece here plus this piece here has to equal this. And so we're going to set up an equation that just uses those pieces. So 3x plus 2 plus 2x equals 22. At this point, once we've solved once we've set up the equation, we're just going to solve it. So we're going to start by combining like terms. 5x plus 2 equals 22. We'll subtract 2 on each side. So 5x equals 20. And then we divide by 5 on each side, and x equals 4. Now, one of the big things about these problems is in algebra class, a lot of times we're going to get this answer, x equals 4, and we're going to feel really good and feel like we have finished the problem. We can't do that here because the problem never asked what x was. The problem asked for the length of BC. So in this case, we, in order to figure out what BC is, well, we know that BC is 2x, and since I know that x is 4 now, I can plug my x in for this x. So it's simply just going to be 2 times x, which is 4, so BC equals 8. All right, so you'll see here are a couple problems for you to try and